In this case, we are given a question which is based on our trigonometry, as we are to consider the part of our trigonometry, the use or the application of the sine rule, the cosine rule, and also the area rule. So these are the basic questions that actually we might be given. So we are going to consider this typical exam question where we are given on question 7, that is 7.1. In the diagram, A, C, E, and B are the vertices of a quadrilateral. So we are given A, B, C, and E as the vertices of the given quadrilateral, and they are given angles and also the sides of this quadrilateral, ABC, which is our angle ABC being 31 degrees, BAC from B to A to C, which is 106 degrees, BAC, which is 46, and also the given length AC, CE, and also BC, which is X centimeters. So from this information and the diagram that we are given, the first question was to calculate the length of BC. Calculate the length of BC. All right, so we have got a quadrilateral that we are given, which is very true. But out of the information that, or the diagram that we are given, we can see that there is a triangle, ABC, and also another triangle, which is BCE. There are two triangles making up the whole quadrilateral. So in order for us to determine the length as we are given on 7.11, in this case, to determine the length of this side BC, we can try by all means to work with the triangles. Remember the properties of your triangles as we worked with the cosine rule, the sine rule. If we were given a portion where the area is given, we can work with the area to find out the given side. But in this case, we are not given any area. So you're supposed to focus on the sine and the cosine rule. But we know these two are supposed to be used when we are having a non-right angled triangle. So where are we having BC? Are we going to use this triangle or are we going to use this other triangle? That is the question. So checking this triangle BCE, we can see that we are limited in terms of the information that we are given. The side that we are supposed to calculate, we do not have the corresponding angle. We are just given one angle, this one, which is not corresponding to any side. There's nothing that you're given there. So meaning to say, in this triangle, we are limited. Let us look into triangle ABC. In triangle ABC, we can see that, all right, in this triangle ABC, we have got an angle 31 degrees, which is corresponding to a given side. There is an angle of 106 degrees, which is corresponding to the unknown side that we are supposed to calculate. Remember this concept where the two correspond. You have a complete set where the angle and side is complete, and the other part, there's an angle and the unknown side, or they can give you the side and you're asked to calculate the corresponding angle. In that case, we know that we can use the sine rule. We can use the sine rule. The cosine rule, to calculate a side, remember we must have an included angle where we are given two sides and an included angle where you are being asked to calculate the third side. You are given these two sides and an included angle. You are then asked to calculate the third side. There you can use the cosine rule. Remember what we had from our introduction. So if we were given this side of AB, let's say we're given this side, we're going to use the cosine rule, but we are not given this side. We must have a side, and an angle in between to calculate or to find the third side. You must be given two sides. You are to calculate the third side. That is the part of cosine. So this one was limited to the sine rule. What does the sine rule state? From the sine rule in this case, so as I stated before, that we are going to consider from triangle ABC. So using the sine rule, remember, to calculate the side, we can use the side on top. Remember, guys, you are used to sine of A over A is equal to the sine of B over B. But I said, if you are to calculate the side, you can have the side on top. So it's going to be A over sine of A. Sine of the angle is equal to B over the sine of B, which is equal to C over sine of C, like that. Okay, do not worry about the other part. What is important, guys? Side over the corresponding what? Sine of that angle. X over what? The corresponding sine of the angle, which is the side that you're supposed to calculate. BC. So we are going to have BC over the sine of what? The corresponding angle there, 106 degrees. This is equal to the other side to the corresponding sine of its angle. What is complete? We can see what is complete is this side. So we are going to have the side over what? Sine of that angle. That is how you apply your sine rule. So that's 4,6 over what? Sine of the given angle. Just like that. So even if we were to use this part where the sine of the angles are on top, still we're going to have the same answer. It is only best to have what you are calculating on top. If you are calculating angles, write the sine on top. It is only best, not to say if you use that other formula, you are limited. No. So what is it that you're supposed to determine? The length of BC. What is limiting us to calculate or to determine this? It is this sine of 106 degrees. So the question is, how are we going to get rid of the denominator? We multiply by it on the numerator. So that's multiply by sine 106 degrees. Remember, this is an equation. Whatever that you're going to do on the left-hand side must also be done on the right-hand side. So we're also going to multiply by sine 106. It is multiplying the opposite. This is in the denominator, so to get rid of it, we must multiply by the sine on the numerator. That is the case. So this can cancel the sine and the sine. We are left with what? With BC. So that's BC is equal to the product of this part. So that's 4,6 times the sine of 106. All right, everything over sine 31 times 1, which is the sine of 31 degrees. So that is what you're going to have. So this can be simplified direct on our calculators. We are not given, in this case, to 2 decimal place or to 3 decimal place. So we follow the instruction of what you're given from that question paper. So in this case, we are going to round off to the 2 decimal place. Okay, let us have our calculators. That is, have a fraction. So this is 4,6 times the sine of 106. Okay, so close this bracket. Then we're going to move down. sine 31. So this is what we're going to have. 8,5, 8, 5, and so on and so on. To 2 decimal places, that's 8,59. All right, we can also just use our calculator direct shift. We're going to go to the setup. Then we fix on number 6. So to 2 decimal places, you press 2. So this is going to give your answer to 2 decimal places, which is 8,59. So that is how we can have our length using the same units as given before in centimeters. So that is the length of BC. The length of BC from what? From sine rule. From sine rule. So this is how these questions will be given as typically in your exam. You just need to play around as many question papers as you can, just try to figure out that understanding. All right, so we have got this side BC. I'm just gonna insert this one 8,59. So this is our BC. So with this part, let us have the other question. 7.12, calculate the area of quadrilateral ACEB. If we are to consider, we are being asked to calculate the area of the given quadrilateral, the whole part. So the question is, how can we determine this area, AC, that's ACEB? If we were so certain of the quadrilateral that we are given, let's say we know that it is a square, or maybe it is a rectangle, another shape that we are used to, we can try to work with the formulas specifically for those areas for the quadrilaterals that you're given. But in this case, we are just given a four-sided shape, which we are not even certain what type of a shape is it. Just a quadrilateral. So we are limited in terms of working with the whole quadrilateral on its own to determine its area. But we know that this quadrilateral is made up of 2 triangles. There's a triangle here. There is another triangle here, where we know the areas, how to determine the areas of given triangles. So in that case, we can separate our quadrilateral into 2 shapes, determine areas of the given triangles, meaning to say the area of the given quadrilateral is going to be a combination of 2 areas. In this case, the area of triangle ABC. All right, gonna combine triangle ABC and this other triangle, which is we are going to also find the area of triangle BCE. This will be the case. Combining these 2 triangles together will give us the whole quadrilateral. Why focusing on a triangle? Because we know its area. That is where we go to the area rule. Of a non-right angled triangle, we know that the area is equivalent to half AB, the sine of C, or the sine of theta, where A and B are the sides that are creating the angle C. So C is an included angle. It must be an included angle. This is what you're supposed to get rid of. We must have an included angle. A and B creating angle C. So where are we having this situation from the given triangles? Working with triangle ABC, this triangle ABC, where are we having this condition where there are two sides and an included angle? That is what you must work with. 106, we do not have this side. We are just having this one. So meaning to say here on 106, we are limited. We are limited there. If we move on to 31 degrees, we have got this side, but we do not have this side. So meaning to say we are limited on this angle. If we move on to the other part, this angle is not given, but there are two sides that are creating that angle, which makes it to be an included angle, just like this condition, where we are given two sides and an angle in between, but that angle is not given. But remember, guys, we are dealing with what? A triangle, so we can determine that angle and work with that part because we do understand angles in a triangle, they do add up to 180 degrees. So the angle that is at C, which is ACB, is equivalent to 180 degrees minus the two angles that are inside the triangle, which is 106 plus 31 degrees. So this will be the case. Angles inside of the triangle. So that was going to give us 43 degrees. So this angle is 43 degrees. Meaning to say the sine rule, the area rule can be used because we have two sides that are creating angle 43 degrees, which makes this angle to be an included angle in between two sides. It must be in between the two given sides. So thus we can have our area. Okay, so from triangle ABC, we are going to have half of A times B, which are the two sides. 4,6 times 8,59 times the sine of the given angle, included angle, 43 degrees. So this whole part that we are seeing is giving us the area of triangle ABC. This is ABC. So we are going to move on to another part. Triangle BCE. So in triangle ABC, we must have the same situation or same scenario, just like the previous case, where there is an included angle. And if we check in this triangle, the only angle that we are given is 46 degrees, this one. That is the only angle. There we do not have, there we do not have. So working with this 46 degrees at C, are we having two sides that are creating that angle? They are there, these two sides. So it makes the 46 degrees to be an included angle. So we're going to work with this side and this side, which are creating the angle. There's a side and another side. The angle is in between. This is what we have here. That is the case of the area rule. It must be in that case. So meaning to say we are going to take these two sides as they are. So that is half of, gonna take 8,59. So that's 8,59 times the other side, which is 10, times the sine of the given angle, which is the angle that is in between those sides. That is what? 46 degrees. So that is the sine of 46 degrees. So this is the condition, guys, that you might be having in an exam. You will be given these considerations. So that part, guys, it is you and your calculator. Simplify. That is 1/2 times the sine, times 4,6 times 8. So this is 8,59 times the sine of 43 degrees. So we're going to close this and close, right? Did we open the first bracket? Right, there was nothing. So just like this. So that is 13,47. Remember, we fixed our calculator to 2 decimal places. So that is 13,47 plus. So simplify this in the same manner. That was going to give you 30,90. Okay. So adding these two, we're going to obtain 44,37. So this is the area combined together. So remember, we are dealing with the centimeters. So area is going to be square centimeters. So area in what? Square units. The square of the given unit. So that is how we play around these questions. It is not always when you're being asked to calculate the area of the given quadrilateral. That quadrilateral, we have the formula direct. Sometimes we must, or we are supposed to separate that into given shapes that we do understand. There we are lucky enough that we can work with what? The triangles. So these are the typical questions that you must be equipped as you are working with your revisions. Another question, we are given 7.2 in the diagram below. PTSR is a parallelogram. The moment you are given this, you know the properties of that shape. It is different from the previous question where we do not even know the shape that we are given. There we are given exactly, it is a parallelogram, where we do understand that opposite sides are parallel and equal in length. Opposite sides, they're supposed to be parallel and equal in length. So as we are given that this is 3, it also follows this is also 3 units. If the whole of this line TS is 8, it means the whole of this line PR is going to be 8 units as well. But in this case, we are given that Q is the midpoint of PR. This Q is the midpoint of PR. So if it is the midpoint, it means we have got equal distance from P to Q, from Q to R. Equal distance. Thus, we are going to divide this one by 2. So meaning to say from P to Q, it is going to be 4 units. From Q to R, it is going to be 4 units as well to give us 8. So this is what you're given, and also this one is X, and also angle T1 is given as theta. Remember that these two lines, they are parallel. So it follows that if this angle T1 is theta, also angle Q1 is equal to theta. Remember the concept of your alternate angles. Alternate angles are equal. So it follows that this angle Q1 is also equivalent to theta. So that is what we can tell from there. It is equal to angle T1, which is equal to what? To theta. So in this case, we do not want to waste time. The question was 7.21. Show that the cos of theta is equal to x squared plus 28 over 16x. Show that is use the given diagram and information to prove that statement. So how are we going to apply this? All right, let us try to figure out. So in this case, we are given, that is 7.21, to prove that, or to show that the cos of angle theta is equal to x squared plus 28 over 16x. So this is what you're being asked to prove. This is what you are being asked to prove or to show that. So let's figure out. There is a part where theta is already given here in this triangle. And also, we figured out that angle Q1 is also equal to theta. But in this triangle that we are given, it is limited. We have theta and a side. There is x, but we do not have this angle P. So meaning to say, we are somehow limited there. If it was something to do with the sine rule, we're going to use something about the sine rule, but here there is a cos. So definitely they want us to apply a cos. The cosine rule. The cosine rule of an angle, it must be a condition that the angle that you are supposed to have as the cosine maybe of A, it must be equivalent to B squared plus C squared minus A squared over 2BC, meaning to say that all sides must be given, all sides. So you'll be given B and C, and this is your A. So this is the angle A, all sides. So that's, this triangle is limited. All sides must be given. If we check what we are given in triangle QTS, all sides were given x, 6, 8, and theta. This is what we are originally given from that part. Okay, if we check this one, from all this part, we had to make extensions of this theta and this 4. And therefore, we can say everything is there in terms of the signs at the end. So when you are to attempt this type of equation where you have got everything in this triangle, we have got all the sides, and in this triangle, we all have the sides. And the cosine rule can be used. So it is not direct to say where exactly are you going to have this, unless you are to check within the size that you're given. All right, this, if I'm to formulate, we are going to have this at the end, but that is unnecessary. You can work with both triangles separated. So when you're answering this type of a question in an exam, it is not a direct question where you just, okay, this is the triangle that I'm going to use. No. You figure out where there is complete information. And in these two triangles, we have complete information. So you work with the given triangles separately now. It will be like a trial and error. All right. So working with this triangle, that is from triangle QTS. Using the cosine rule of determining the angle, we can see that the cos of angle theta must be equal to, from this formula, guys, the cosine of the given angle is equal to B squared plus C squared, which are the sides creating that angle. So in this case, the sides creating our angle is x and what? And 8. So that's x squared plus 8 squared. Minus a squared, the side that we are subtracting is the one that is opposite the angle that you are working with. You are working with theta, so the side opposite that angle is the one that you must subtract. So that's minus 6 squared. A side A. This is the concept. So B and C, they create the angle that you are working with. So this is over 2 times B times C. As we can see, it's a repetition of these two sides. So that is 2 times X times 8. This is the concept. So let's simplify this one and see. Cos of theta is equal to x squared plus 8 squared, which is going to give us 64, minus 36, everything over 2 times 8, which is 16x. So that's 16 times x. All right. So simplifying this, we're going to have the cos of theta equal to x squared 64 minus 36. That was going to give us 28. Everything over 16x. All right. So we can see that we are obtaining this from triangle QTS. That is where we are having this part. But in this case, it was not an exact thing because also there is triangle PQT, which also has theta there, and we also have x on it. So let's see from that triangle, if we were going to have the exact value of that expression of the answer that we are given, I mean the exact expression of that. All right, so let's see so here is just checking. We are just to check with this one. If we are going to have the exact value, the thing is the cos of theta will be representing the same thing, even though we are going to have different answers. Let's say we are going to have different expressions or different presentation of the answers. Those cos will be representing the same thing. But we want to check if we are going to have exactly this presentation. The issue is seeing or proving that this presentation can be obtained or not. All right. So like I said, the cos of theta will be equal to, in this case, we are working with this theta. So as we head from the formula, b squared plus c squared minus a squared over 2bc, the b and c are the sides that are creating that angle theta. So we've got 4 and what? And x. So that was going to be x squared plus 4 squared minus the side that is opposite facing angle theta. So that is 3 squared. Everything over 2 times b and c, the sides that we're adding before. So that is 2 times x times 4. All right. So this is the cos of theta, which is x squared plus 4 squared. That was going to give us 16 minus 3 squared, which is 9. And that is 2 times 4, which is 8. So it was going to give us 8x. So simplifying this part, we are going to have x squared 16 minus 9, which is going to give us a 7 over 8x. So this is what we are going to have as a presentation for the cos of theta. In this case, we are not having exactly as given on the question here. So meaning to say, this triangle was going to limit us in terms of the answer. Guys, we used the cosine rule in the exact manner, the way that it is supposed to be used. Maybe that is how you worked out the first part. Maybe you worked out from this triangle, which is from triangle. All right, this is triangle PQT. Maybe this is what you worked with. Then you see that the answers are not exactly the same. Meaning to say you go back to the other triangle where there is a theta. Which other triangle? We saw that there is triangle QTS. And in this triangle QTS, that is where we obtained exactly the expression that we are given there. So that is why I'm saying this type of equation, it is a trial and error. Where there are two triangles and theta is there in those two triangles, and also x is there. You cannot say, I'm having this triangle as my exact triangle. No. Let's be sure, let's be certain about how to answer questions. The issue is, how are you going to answer this question alone in exam? So you work it in that way. So as we can see, guys, the exact part was going to be from what? Triangle QTS. So that is the part that we are going to have. But in most cases, you see that they won't allow you to just leave that information that you worked with. Let's say it's a trial and error, then you worked something that is exactly having the cos of theta. They will need you to use that part. This is what exactly they want you to use on 7.1 or on 7.22. Hence, from what you have calculated before, determine the length of QT. Hence, determine the length of QT. QT represents what? Represents X. This is QT. It represents X. So in other ways, the question is, find the value of X. In other words, the question is simply, find the value of X. But they said hence, meaning to say we are supposed to have a continuation from this question. Where X is from what we calculated before, we can see that there are two unknown, X and also theta. So let's say we were given theta. Let's say we are asked to determine the value of X for which theta is equal to. You are given maybe theta is equal to 30 degrees. Guys, you're going to just substitute here 30 degrees, then you simplify. But in this case, we are limited. They never gave us that condition to say for which value of theta. So meaning to say, we cannot work with this alone because it has got two unknown, X and theta. So in this case, we must find another part which represents the same cos of theta, this one, in terms of X. So are we having the cos of theta in terms of X? Why in terms of X? Because that X that we are supposed to calculate is the one that represents QT. There is this one in terms of X. And remember, when we were doing our trial and error, there is a cos of theta that I said it is exactly the same cos of theta. The only difference is the answer, the expression, different presentation. But what does it represent, guys? It represents the same cos of theta. Let's say theta is 60 degrees. If cos of 60 degrees is equal to 0, it is 0.5. It is not going to change, guys. This is what I'm trying to say. We have cos of theta written in different manners or different ways, but representing the same thing. So we are simply going to equate the two parts that we obtained before. The cos of theta that we obtained here, and this cos of theta that we're also using on our trial and error. So you see that even if you did not use this part on your trial and error, you're still forced to go back to find this part. You see our mathematics, how they play around with us, guys. They know that you had that part on your trial and error. So equate the two because they represent the same thing in terms of x. So the first one, we got x squared plus 28 over 16x. On the other one of our trial and error, this is what we got, x squared plus 7 over 8x. So we're going to equate these two, x squared plus 7 everything over 8x. Thus, we have formed an equation that we are going to solve for x. Solving for x means determining the length of QT. So that is the question. So how can we solve, guys? We are back now to our equations. Cross multiply. We apply whatever that is applicable, guys. So we're going to cross multiply this part. That is 8x is going to multiply x squared plus 28. 16x will multiply the whole of this part. So this is 16x multiplying x squared plus 7. Expand the brackets. So distributing this by 8x times x squared is going to be 8x to the exponent of 3. 8x times 28, that was going to be 224x. Okay, so this is equal to, we multiply this, the 16x to the exponent of 3, 16 times 7, that is 112x. So that is what you're going to have. And as we can see, they are like terms in terms of the x cubed. There is this part where we've got the x cubed there. So we can just ignore the other side and let it be equal to 0. So take this one to the other side. It was going to be a negative. As it is a positive, it's going to be a negative. So that's 16 minus 8, which is 8, x to the exponent of 3. These are also like terms. We've got x and x. So take this to the other side. It was going to be a negative again. So 112 minus 224 is minus 112. So this is it. Guys, it's an equation. If A is equal to B, it means B is equal to A. So meaning to say if the right-hand side and the left-hand side are equal, we can start with any side. We can even say 8x to the exponent of 3 minus 112x is directly equal to 0. So that we have got x on the left-hand side. Even on the right-hand side, I do not mean, guys, to say it is going to affect your answers. No, that one is not going to affect your answers. But the question is, what will be the value of x? We have x here. I said never divide whenever you're given an equation. It is best that you factor out, not to get rid of that x. Dividing by x, it means we are getting rid of some of the solutions. So in this case, we are supposed to factorize. We have got two terms, guys. Remember the golden rule of your factorization. Factor out the highest common factor between the two terms. So in terms of the numbers, 8 and 112, that is 8, 112 divided by 8, that is what? 14. So meaning to say, we can factor out 8. Then between x to the exponent of 3 and x, the highest common factor will be what? Will be x, the one that has got what? The smallest power or the smallest exponent. So you're going to factor out 8x. 8x to the exponent of 3 divided by 8x. This was going to cancel this into this. That is going to remain with x squared minus 112 divided by, so it's like this, divided by 8x. The highest common factor, x and x was going to cancel. Then minus 112 divided by 8 is minus 14. So that is equal to 0. So you factor out the highest common factor, then divide each term to the highest common factor. Remember your factorization, so that we have got this concept of the zero product, the product of two to be equal to 0. It means one of these two must be equal to 0. So it is either 8x, it is equal to 0. Or we are going to have the bracket of x squared minus 14 being equal to 0. So that's it. Solve for x. All right, divide by 8 by 8. This side, that is going to be x is equal to 0. Or on the other side, if we are to take this to the other side, it's going to be a positive. Remember, we just have two terms. So we're just going to take this to the other side. So x squared is equal to 14. Introduce the square root, knowing that the square root of any number is what? A plus or minus. So that's 3,74. In this case, we are dealing with x, which represents the length. So we cannot say the length is 0, guys. From point A to point B, there is 0 unit. No. There must be a certain distance. So meaning to say, in terms of length, x cannot be equal to 0. And also on these two solutions that we determined, plus or minus, the length is always a positive. We take the magnitude, which is the positive value, the magnitude. So therefore, our length, which is the length of QT, the one that we are given, which represents x, like I said, is equal to what? 3,74 units. So this is how we answer these typical questions. In this case, guys, you had to find a part which can be equated, where you can equate two expressions in terms of x. Two terms which represents the same thing. So we had to work with the cos of theta and cos of theta. If there was something that has to do with sine of theta, let it be equated also to the sine of theta, as long it is in terms of x. You formulate equations in terms of what you're given. So these are the typical questions that you might be given. You just need to work out as many questions as you can, try to figure out how to attempt these typical questions. It's not always where questions are direct. It's not always. Sometimes they want you to play around with these questions. Understand all the basics of your trigonometry. That is the basics of your triangle, sine rule, cosine rule, and the area rule. So this is what you're going to be working with as you are preparing for your exams, which are ahead of time.